put you right here on the side. Okay. All right. So this link that I sent you, which is, I guess you can see my screen. Let me know if it's the text is big enough and all of this. Okay, I can make it bigger, smaller. I prepared this workshop so it's interactive and everything's online, which means you don't need to clone anything, no Git, no installing, no npms, none of this. Okay. I'm going to assume that most of you know JavaScript or the basics. I know that some of you do, but some of you I don't know you. So if you don't, it's quite easy. Just follow along. It's basically just a bit of copy paste. Okay. I'm going to teach the basics, the very basics of D3. And basically the things that I'm going to teach, every little section has a little code snippet or something that you can copy. You can run live and then you can see the result. So it's pretty much all done for you and you can just follow along. And it's also pretty much everything is written down, so you can actually do it now or you can do it later if you want. Okay. So that's, I'm just going to start. By the way, you can stop me at any point. Okay. You know me, you can ask me questions. I don't mind. All right. Okay, so that's what it says in the first part. So this is I'm using this tool called Observable, which is for live notebooks, which basically all that you can see, and that's the link that I shared with you, everything you can actually edit it online. Okay, all of those things, if you hover anything and you click, let's say to the left, you can see that below of this something is going to open, which is in this case just markdown text that you can actually edit live. Okay. If you edit the link that I send you, you're going to see all the results, but then if you refresh the page, you're going to lose your results. So if you want, I'm going to give you 2 minutes. If you want to create an account, it's free, obviously. You can just log in with GitHub and all of this. The advantage is that then you can fork this notebook, and then you're going to have it in your account, and then you can make all the changes that you want, and the changes are going to be saved for you. Okay. So I'm going to let like 2 minutes so you can create your account if you want, and then I'm going to start. All right. So let me know if you have any trouble with this or anything. Okay?
Sorry, can you just let me know what I have to do exactly, because I'm new here and
so if you open right now, I'm logged in, but if I'm going to open this in a new window. Wait. So if you open this in your browser, you should see something like this, and it says this is live code, etc. You can click on the left margin and edit anything. What I was suggesting is that you fork this. To fork this, I think that you need to have an account, so you can sign in. You can use any of your accounts to sign in, and then you can fork it. Actually, I can see the fork button right here, so maybe you can fork without having an account. I don't think so, but you can try. Okay.
Okay.
But I think you need to create an account, not sign in first, right?
Yeah, probably. Again, as I said before, you actually don't need to do this. If you don't want to create an account, you can just actually edit all of this right here. The only problem is that then if you refresh your browser or you close your browser, you're going to lose all your changes. Okay. That's why I suggest that you create the account. Okay, let's have just 1 more minute and then we're starting.
Somebody says they're getting a 500 error.
All right, 500. We all know it's a server error, so it's not my fault. Let me see.
And Germinal, a couple more people have just joined. So maybe if you could just repeat that and I'll put the link back in the chat for them.
Sure. So someone is getting a 500. I know this person. A 500 error. Refreshed. All right. I mean, all good. All right. If anybody gets any other trouble, let me know. Okay, if anyone just joined right now, I just shared a link on the chat. It's this link right here. It says Observable HQ and then it's the D3 workshop. If you open this, exactly. If you open this, you can see this page. I was just mentioning that you can actually create your own account. So sign in, it's free and easy. And then you can forward this notebook. This way, any changes that you make live, it's going to be stored in your account, okay? Otherwise, if you don't want to do this, you can still edit all the code live. But then if you close your browser or refresh the page, you're going to lose your changes, all right? Or obviously, you can just, if you want, just watch me do the things, okay? But since this is a workshop, it's like a hands-on thing. Everybody can edit things, can try different things, okay? Let's make this as interactive and fun as possible, okay? Okay, forked and ready. So I think I'm going to start. Usually I don't read the chat, so if there is something super important happening in the chat, any of you can just unmute yourselves and just let me know, okay? All right, so where to start now? What I just said about observable, if you click on the left hand of anything, which is any text, actually, the text you don't need to change it, but even something like this, which is a drawing, you're going to see the source code for this. Okay, in this case, I can use any type of code in here. I can use HTML or Markdown or SVG or mostly JavaScript. Okay, this is a live tool to work with JavaScript. Now, there's a few differences between the language in observable and JavaScript itself. It's actually not the same thing, although it's very, very similar. There's just a few differences that you might notice along the way, but it's pretty much the same thing, and it's a very good tool to actually demonstrate things live, okay? So we're gonna talk about D3. D3 is, I'm just gonna show you their website right away. This D3 is this library written in JavaScript, which is intended for manipulating data and generating graphics based on that data. So there's a lot of data these days, and we want to represent this in a comprehensible way. And this library just gives us a lot of nice tools to, draw circles and rectangles and just shapes and lines and do bar charts and scatter plots and maps and all of this, okay? There's a lot of things to do this super, super fast. It takes some time to adjust to the syntax of D3, but when you sort of know how it works, it's actually quite fast and quite fun, okay? So, first thing, I'm going to talk about SVG. SVG, you probably know what this is sort of a markup language like HTML intended for drawing things on the screen. And any tag in SVG looks pretty much like a tag in HTML. For instance, to draw a circle, we could use this tag. Okay, circle, we can say, we can set a few properties like the x coordinate of the center and then the y coordinate and then the radius of the circle. These will output something like this, okay? Just for this example, this is just sample code. And the way that I actually wrote this that you can see right here is like this. I inline some SVG, which is the main tag, with a width and a height of 720 and 120, and then the circle inside of this. You can see that if I change, for instance, this for 20, the radius, I don't see the changes yet because I didn't run this cell in observable. I didn't compute this code. If you want to compute this code, you have this little run cell button to the right of every cell. If you just click on this, it's going to update that code for you. Okay. You also have a quick way of doing this, which is if you're on a Mac computer, is Shift Enter. Okay. If you edit anything like this and you do Shift Enter, it's going to modify the code right away. On a Windows computer, I don't know how this is. It must be something similar, maybe Shift Enter. And in any case, you can always use the play button to the right. Okay. So this is how we draw a circle in HVG. It's quite easy. And then it sets a few arguments. Okay, the center, the radius, and all the stuff. For styling pretty much everything, we can style the color, or like the fill color, or the color of the stroke. If we want a straight line or a dashed line or a dotted line, all of these we can change it, the stroke width, the transparency of elements, anything related to visual aspects of the drawing, we can change it with SVG, okay? So for instance, to draw 3 little circles, which is going to be like the main base code for today, you would do something like this, okay? As you can see, this is the code that I just wrote. So 3 circles, each one of them has a different center and the same radius. Okay, we can draw many shapes in SVG. Okay, basic shapes. You have, well, rectangles, circles, lines, polylines, paths, which are a bit more complicated, etc. Okay, lots of stuff. So, as I mentioned, you can modify all of its attributes using this. Hey, you know what? I could actually read the whole thing because I wrote it, and those are like my thoughts. And when I just speak out loud, I'm saying the same thing that's actually written. So, what is D3? D3 is a library that allows us to manipulate those elements, SVG and actually any HTML element on the DOM. Most of you know what the DOM is, based on data. That's the key thing. Everything will start with data. We can have some sort of data that we want to represent, and we're going to link that data to the drawing that we want to make. Okay? So the advantage of D3 is that since it's JavaScript, it's not just setting the tags manually like this. We can manipulate the elements programmatically, so with JavaScript code. For instance, to draw the same thing, the same SVG with just one circle that we just did at the top, we can do it with this code right here. Okay, this code renders this. By the way, as you can see the code for this because I actually pinned this. If you unpin this cell and then you unfocus the cell or focus another cell, you will lose the code. Okay, but it's always to the left. You just click one more time and it appears again. Okay, I'm going to pin it again. So this is like the basic code for creating this drawing in D3. There's something to this code which is unique to Observable, but it's pretty much the same thing if you were to do this in a plain HTML file with a JavaScript file, okay? Just a few differences. So I'm doing basically 2 things. The first one is I'm going to create the canvas, which is the SVG container that I'm going to draw things in. And there's a quick instruction for this in D3, which is D3.create SVG, and then I can say its width and height attributes. That's it. In all the examples, this is already done for you. So we're going to focus on the part in the middle, which is manipulating the contents. Okay. Then the other part at the end, this is unique sort of to Observable. We need this so Observable is able to render this on the page. So this sentence return svg.node, a bit confusing, but just ignore it for now. It's there in all your cells. You don't have to modify it. This is the important part. That's what I want. We have an SVG container which we stored in a variable, which is a constant variable. So now we can append things into this. Okay, we all remember the DOM. We can append child to all elements in the DOM. That's what this is doing. Okay, to the SVG container, I want to append a circle, and after calling this, I can chain a few of the attributes that I want to modify. That's how I would create the same circle programmatically. Okay. Notice if I change the center Y or the center X, for instance, I'm going to put a 16 here. I'm going to rerun the cell. And now the cell is here. If I change the radius to be 50 and I rerun the cell, now the radius is 50. Okay? Pretty straightforward, I would say. Am I going too fast, too slow? Is it all right? Good. All right. I'm going to keep moving. So we just saw the D3.create and then the append method to add elements to the page. So the first little exercise, all the exercises are very, very simple. They say code along and it says add 2 more circles to this code using D3 that will generate the SVG shape that we saw before. So we want to generate this, but using only code. Okay, so I'm going to give you 1 minute to do this and I'm going to do it myself. I just want 2 more circles. So by the way, I'm going to say that the way that I structure this is that we work always with the same code and we keep adding things into it. But since I didn't want you to lose the previous code so you can have all the steps, what I'm doing pretty much in every code along section is that I give you the code that should be done from the previous cell. Which means if you just scroll down, you're going to find the solution to the previous exercise. So So the point is that you don't do this, right? You just try to follow along. Nurjan, I think you just unmute your computer, no? All right, so hopefully you did something like this. You can actually just copy paste. Okay, that's what I'm gonna do because I'm super lazy. I'm just gonna copy a second circle, which was in the position, let's say 80. So I'm just gonna change this with an 80 and rerun the cell. There's the second circle, and then I'm gonna add the third one, which is in position 120. So 120 and rerun the cell. Okay, this is the result. Hopefully everything got something like this. I'm going to move to the next one. So that's how we add new elements. There is something that we can do, which is selecting current elements that are already on the page. Maybe we want to select elements so we can manipulate them later. Okay. There is actually two methods for this, which is the D3.select or the D3.selectAll. Obviously, one is from just one element. The other one gives you back an array of elements. And the selector that you can pass in is a CSS selector. Okay, this is pretty much a query selector or a query selector all behind the scenes. Okay, so if I just tell it to select every circle from within the SVG, it's going to give me something back, which is sort of a collection of all the circles that I have within the SVG. I'm doing it like this, so later I can manipulate them, which is the next section. So now that we know how to select the elements, we can manipulate them, which means changing any of its attributes or styling. So it says we can change the fill style to paint the circle a certain color, or we can programmatically change the radius of the circles. And it says code along. Add this code to the cell below to change the styling of the three circles. So the idea is, again, you just copy this and you paste it. Remember to click to the left. You paste it right here so you see what happens, okay? I'm gonna give you 30 seconds and then I'll do it. All right, I'll do it already because this is just copy paste. I'm gonna copy this and I'm just gonna paste it in my code. Okay, one more time. I'm selecting all the circles and then I'm changing the style attribute of that circle, and the fill, I want to make it steel blue, which is a color. And then the radius, I want to make it 30. Okay, the moment that I rerun this, that's what I get. Okay, it changed the color and the radius. Okay, we can modify again any attribute of the circle. All right, is there any questions so far? Nope. So next thing. We're going to use a lot of times this method chaining syntax, which is, you've seen this a lot of times. Once I've selected something, I don't have to do circles that style and then circle that attribute and then dot, dot, dot all the time. I can actually put this on the same line, okay? Because every method is going to return to me again the whole selection, so I can still apply the same methods into it. So I can do the same code with just this line of code, all right? I'm just going to replace it. There you go. I'm going to actually, wait, I didn't select the elements. I'm going to rerun the code. The result is the same, but I have this in one line. Okay, circles.style.attribute, and I could do more .attribute, etc. Okay. So this is like the basics of selecting and manipulating, and then now the most important part comes in, which is binding the data. Okay, the real power of D3 comes when we deal with data. Any application we can think of is about data that we have and we want to communicate with the user. How many times have you heard me say that, right? So D3 allows you to bind any type of data to the SVG elements of the page, okay? In this case, we will use data that we have to drive the appearance of our circles. And for this, we're going to use the data method. This method is going to bind an array of data to our selections. So if I have my selection of circles, I can bind some data to it. The data that I'm binding, in this case, I have 3 circles. I'm just going to pass in an array, which is going to have 3 numbers in it. I don't know what those numbers represent yet. They're going to do whatever, okay? So the first value of those 3, the 32, is somehow bound to the first circle. based in this case in the order in which I created them, or in the order that they were selected from the page. So the second number is going to be bound to the second one, and so on. Okay, if I have 1 million elements and I bind 1 million data, that's the order of things. So I didn't do anything with this yet, because I want to talk about the other part, which is what makes this really powerful. So we just saw how to manipulate attributes by doing something like this: style, and set this to blue, or the radius to be 30. This is nice, but this is pretty hard coded. Okay, but in D3 we can have attributes as functions of data. Every property in a selection, when we select the circles, can be treated as a function of data, not just a plain value, not just like a string or a number or anything like this, but an actual function. So this function will be called for every element in the selection, receiving that element's data as the argument of the selection. So in this example, we want each circle to represent each number through the radius. So the bigger the number, the bigger the radius of the circle. Since we can manipulate the R attribute, the radius, for each circle in the selection, we can do so using a function. This code right here is going to give us a representation of the numbers using R circles. So when I change the radius attribute, I can just set a 30 right here, or I can actually inline a function that's going to receive automatically as its only argument, or the first argument, the data that was bound to that element. When I did the dot data before, okay, when I did this, I'm going to receive the 32 for the first element. So if you know JavaScript, you know that this syntax, we can actually have it quite shorter in using the arrow syntax. And what this means is something like, for every circle in our selection, make the radius have the value of the data bound to it. I'm having the value, and I'm returning the value to be the radius for that specific circle. So actually, this code belongs down the code. Let's do the next code along. It says add the previous code, data binding and setting the radius attribute, which is both this part plus this part. Let's add this to our current code, which is this, and let's see what happens. Okay. I did select the circles for you. I changed the circles colors, and you need to do two things: bind the data and change the radius. I'm going to give you 2 minutes to do this. So the first part is, I'm just going to copy it, which is this. To my circle selection right here, I'm going to bind some data, just 3 numbers. And then to that selection of circles, I'm going to set the radius attribute, which is this, the radius, not in a constant number, but as a function of data, something like this. For every piece of data, return that piece of data and make this be the radius. If I just run this cell, 1, 2, 3, run, I get something like this. Okay, the problem is what I said before, which is, are the circles too big? Since the radius attribute is a function of the data, we can actually perform any transformations into this before returning the result. For example, we can divide the data by 4 and use that number as the radius. So right here, actually, well, actually, this code is right here. I just duplicated this. If you just copy this, or you just can write it right away, instead of returning the data itself, you can return the data divided by 4. If I run this cell, 1, 2, 3, there you go. Every circle is proportional with its data, but I made it fill into the space available. All right. Remember that this is just a function, so you can perform any logics that you want. Okay, it could be 100 lines of code, no problem. It's just a function to calculate what the radius would be for that element. So there's a second optional argument to each function that you can also use, which is the index of the element within its selection. Just like the map function in JavaScript, most of you know about, I hope. So the index is often useful for positioning elements sequentially, okay? If I use the same logic, this time for changing the center X attribute of the circles, for every one of them, I'm gonna receive, yes, the data, but also the index in which they are. If I just return the index times, in this case, 100 plus 30, I'm gonna put every circle in a specific position. So it says add the previous code, which is this line, setting the horizontal position of the circles to our current code. So if you just click on this, you can do this right here, okay? I'm gonna give you 30 seconds to do this. All right, so I'm going to do it right away. I'm going to say something like circles dot attribute. I want to change the center X attribute of the circles to be a function of data in which I accept the D and the I. And I'm going to return, we said something like I times 100 plus 30, I think. Something like this. So I'm going to rerun this, and now I get this. Same circles, but I can actually change their positions rather than just the radius. Okay? Is it making sense so far? All right, so let's move on. So the next one, we've been working with 3 circles so far, which actually were already on the page because I created them the first thing, 1, 2, 3 circles. What happens if our data set has actually 4 pieces of data, or 50, or 1,000? So actually, that's where D3 is very good, because it doesn't rely on the previous elements that were on the page. We can create new elements as we need them. We have the enter method for this, okay? It allows us to decide what to do with the incoming elements that weren't there before. I have 4 pieces of data, but only 3 available circles. What should I do with the rest of the data? So the enter method, it will return an array with as many positions missing in the SVG that we need to match the number of selected elements in our data. So if we had 3 elements in the SVG and I'm binding 4 numbers in my data selection, the enter method is going to return to me 1 extra circle that it's going to create for me. So it says, let's bind a new array of data to our circles, this time with 4 elements. After calling the enter method, we can call the append method to create all the missing elements. What do I want to do with all this reminding data? Do I want to create circles? Probably I do. But I could actually create all the things different than circles. So let's use method chaining in order to set all the attributes for the new circles in one unique expression. So the code along is this. I just wanted to copy paste this code into here, and let's see what happens. Okay, I'm going to read this code quickly. To the circle selection, I'm going to bind 4 datums, and then I'm going to enter for the new entering elements, which is going to be 1. And for that one, I'm going to append the circle. I'm going to fill it with a specific color, and then I'm going to set its attribute. Okay, the center, the center X, the center I, Y, and then the radius. So if I just copy this into here, hopefully this will work. Copy, run the cell, and that's what I got. Okay, notice that I'm only painting the last one because after the enter keyword, sometimes you're going to see this like with a bit of indentation. Because when you enter the selection, it's only the entering elements, only the new ones. So for the new ones, what do I want to do? Well, I want to make a new circle, fill it with a specific color, etc. So I have the 3 original ones plus the new one to the right. All right, which is basically what it means is I don't really need any existing circles on the page to create circles. I can just have no circles, make a new data binding, and then for every entering element into that selection, I can decide what do I want to draw. which is usually the case. You're not going to start with 3 preset circles and then reset them. You're going to have nothing, and then you're going to set them from scratch. Okay. So exactly, that's, see, I should just read my notes. This logic will still work even if there are no circle elements to start with. In that case, the ended method will return an array with 4 new elements. So it says the code along is just remove all the circle elements from the previous cell and rerun that cell. So if you just go up here and you completely remove those 3 original ones, and then you rerun that cell, well, we still have 4 circles. It's true that's not exactly the same because I didn't style the first ones, but I get 4 circles in which each one of them I set its center attribute, the radius, and the color. This is sort of the idea. All right. So far, so good. Yeah. All right. So moving on. Exiting elements, the same approach that I just did for the new elements. I can do it if I have less elements than I need. So if I have a data selection and I only want to use 2 datums in this case, what happens if I had 3 datums on the page or 4 of them? Well, I can just call the exit method, which is going to give me an array with all the leftovers. So I can decide what to do with them. Maybe I want to remove them from the page, or maybe actually I want to keep them, but maybe I want to style them differently. So that's what the first code is doing. If you go to this section in the code along, that's the previous code that we have. You can insert your new code in here. And if you try the first one, to the exiting selection, we're just going to style them in red. So I'm just going to copy this. I'm just going to paste this in here. And I'm going to run the cell. And notice that this time I was finding 2 datums. So the 2 to the right were leftovers. And to those guys, I decided to paint them red. Maybe it would have made more sense if instead of this I changed the opacity of something. I think I can change the opacity like this, opacity, and set it to, let's say, 0.25, and there you go. Those elements were there, but now they're going to disappear or something, okay? This is sort of the idea. If we actually want them gone, like for good, we can just remove the selection, okay? We have the remove method. So if instead of doing this, I'm just going to comment it out, okay? If instead of doing this, I just do dot remove and rerun the cell, there you go. Only 2 circles, okay? All good? Moving on? All right. So obviously this is this concept in a Venn diagram, okay? We have current data in the page that might need updating, by the way, when we have a new set of data coming in. And then any new elements that we need are going to come into the entering selection and any exiting elements into the exit selection, okay? A lot of times when we need to change the data, we need to decide what to do with those 3 things: the entering, the updating, and the exiting elements, okay? So those things that we just saw are like the basics for drawing things and selecting things. So now let's talk a bit more about data visualization, okay? In the beginning of the exercise, the circles didn't fit the canvas. When we made them big, they were way too big. So we had to reduce the size by dividing the radius by 4. And we used the resulting value to define the number of pixels that each circle would take. So that was quite an arbitrary decision, because we used the values to directly define the size in pixels for every circle. A lot of times, we need to work with a canvas that has different dimensions, or we might have to represent the data that cannot be converted to pixels that easily. What if we're representing the population of a country? Should we draw circles that are millions of pixels wide? Obviously not, okay? So we have a special tool for this, which is the Scale tool. Okay, Scale is a tool that maps an abstract dimension of data to a visual variable. We're going to have numbers coming in as data, and we want to represent them somehow. So we want to transform them in, a lot of times it's just pixels and positions and stuff like this, but then there's other visual variables that allows us to understand the data. So scale is going to transform a number in a certain interval, which is the domain, that's where the numbers live in, the domain, into a number into another interval called the range. And this animation is not mine, by the way. I'm going to talk about later about Observable, how I import other animations. But this is sort of I think, a very graphic way of visualizing this, which is if our data belongs in this domain, let's say from 0 to 10,000, and we want to draw this somehow in the screen from the first pixel to the last pixel, well, we want some sort of transformation that for every incoming number, it's going to give me in which pixel I should draw this thing. Okay, one more time, I hope this makes sense. So the scale is that function that transforms one data to another data. Hey, between you and me, it's just a division, okay? But it has a fancy name, it's a scale, all right? So we're transferring from the data space to the visual space, something that we can see. In a lot of cases, the transformation between the domain and the range will be a linear transformation, which is what you just saw right here. But it's not the only type of transformation that exists. Let's assume that we know that our data is always between 1 and 300. This should be sort of the domain, the minimum and the maximum. We want to position our circles across the horizontal axis of the SVG canvas, which is 720 pixels wide. So for this, we can create a scale that we're going to use in the drawing. For that specific example, please note that I'm not creating this scale in its own cell like I did before. I'm actually creating this directly in Observable so I can actually use it later. Okay. The way that I did this, and it's done for you, is I call it D3.scale linear, which is one of the functions of D3. And then you can pass in the domain and the range. Okay, so I'm saying that for that scale, the data domain is going to be from 1 to 300. And I want to map this to a visual domain that's going to go from 0 to 720 that I'm going to use for pixels. So I'm going to create just the scale. The scale is just a function. It's going to return to me a function. That's what you can see right here. Linear scale is just a function. So by the way that Observable works is that you write some JavaScript code, and when you run the cell, the result is going to appear above the cell. It's sometimes a bit confusing, but it actually works fine. Okay. So this is just a few examples. Okay. If you call linear scale with the value 1, the idea is that if the 1 is the one more to the left, it should be represented with the range value more to the left, which in my case was 0. So the 1 gets mapped to the 0. The same way, the 300 gets linearly mapped to the 720 for the outgoing range. Anything in between, for instance, the middle point, sort of the middle point between 1 and 300, which is 150, it's going to be right in the middle of that scale. Notice that it's actually not the middle, which is 360, because this scale didn't start at 0. All right. If I start this scale at 0, from 0 to 300, and I rerun this, notice that everything is recalculated, and now that's right. Don't pay attention to those zeros, that's just JavaScript rounding issues. Okay. So again, all of this is live. You can modify anything that you want. Just play around with it, okay, and see if it makes sense to you. I'm going to change this back to the 1, and there you go. And this actually is the most useful tool in D3, I would say, the scale, okay? Because we can map from anything to anything. I can even change, look at this, I can say minus, whatever, 720 and 0, which is sort of like inverting the scale. I just need to tell you the domain and the range, and all the operations are going to come for free. Okay, so you can create more if you want. You can add a new cell and say linear scale of, I don't know, 15. You run this, and it's going to give you the resulting value. Okay, so this is how it works. So now let's redraw our circles with a new data set. I'm going to give you a longer data set. Okay, and we will now use a brand new linear scale to position our circles horizontally through the center attribute, which means I was using the data to set the radius, but now I'm also going to use the scale to position the circles across the x-axis. So let's code along this. Right now it's empty, but your code just belongs here. Let's have 30 seconds. You can copy these and just paste it here and see what happens. right? I'm copying this myself. I'm gonna paste this in and I'm gonna run. And it doesn't work. Why not? Is it working for you? Yes. Let's see. Run this. Run this. Okay, I'm not sure why it's not running. I'm just going to refresh my page. Scroll down again to that position. Okay. Okay, it's not running for me. Not sure why. Oh, because I changed the linear scale. Oh, all right. That's fun. I was playing with the linear scale and I inverted the, the order. And since everything is connected in observable, everything is live, I fucked up. So I'm just going to go back to the first one. So from 0 to 720, there you go. Run this, there you go. Those are the circles, okay? Rookie mistake. All right. So right now I'm using the data for every circle to style two things, actually, which is a bit redundant, but for this example, it's fine. I'm mapping the data to the radius of the circle and its position across the x-axis. Okay, this is what we get. So obviously, it's always increasing because of this thing. All right. So I wanted to notice this. Can you see where we use the linear scale in the CodeOp? I just did this. If you know JavaScript, you know that if they expect me to put a function in this, I can actually inline a function, or I can just reference the name of a function. So the linear scale function, it's a function, there you go, that's going to take one number. That number is going to be the data. Okay, remember, this is like doing this, okay? Get my data and run it through the linear scale function and return this. Okay, hopefully you know what I'm talking about. D, fat arrow linear scale D. But when you have the D and the D, you can remove this and you can just point to this, okay? It makes for sure the syntax. All right. So the last circle looks a bit too big and falls out of the canvas, this guy. We are currently applying a linear transformation to decide that the radius of the circle is going to be D divided by 4. We can create another scale, maybe a logarithmic scale or a square root scale, to represent the radius of the circle. So we have D3.scale linear, but then we have D3.scale square root, and then logarithmic, and then there's other scales as well. I'm going to show you later, okay? So I'm going to create another scale for this, which is a square root scale. And the domain is going to be from 1 to 300, which is the data domain. And basically, I want the maximum radius to be 50. The minimum to be 0, the maximum to be 50. So if you code along, it says modify the previous cell. So you can just go up in this code. So the radius is calculated with the square root scale that we just created, okay? Let's see if you can do this. So in this code right here, you can modify something so the size of the radius is different. I'm going to give you 1 minute and then I'll do it. I'll be right back. All right, so hopefully what you did is this. We just need to use the square root scale, which is called scale, to set the radius. If I just rerun that cell, there you go. Now, same logic, but now I can fit the circles into position. Okay, and now it's not a linear scale, which means it doesn't grow linearly, okay? It grows with a different function. All right, does that make sense? Hopefully, yes. I'm going to move forward. So, D3 scales come in many types, which you can use depending on the abstract dimension that you need to represent? Is it a quantitative dimension? Is it nominal? And what's the visual variable that you want to display? Is it a position? Is it a color, etc.? This is why there's another type of scales, which is only for representing color. Okay, position is the strongest visual variable, like where things are placed on the page. But then color can also be used as a scale. That scale is just a bit different. It's called a sequential scale. It's similar to linear scale, except that the range relies on something called an interpolator. Okay, an interpolator is just a function that takes a value between 0 and 1 and returns the corresponding visual value. Basically, it works just like a normal scale, in which we tell it what's the initial value and the last value of the color that we want to interpolate, and then we're going to receive a scale that's going to do this for us. Okay, so we're going to use it like this: D3.Scale Sequential. We set always the domain, and instead of setting the range, we set an interpolator, which is going to be either something which is built into D3 or something that we can create our own. Okay, if you just click on this link, D3 built-in color scales, color schemes. You can see some of them which are built into D3. Okay, pretty useful: blues, greens, oranges, etc. And then scales with multi-hue, which is they go from one color to many colors. Okay, and then you have diverging scales, very good for I don't know, for a lot of stuff. And then you have things like categorical scale. Sometimes it's not just a range, it's just discrete values within the name, okay? So there's another type of scales for this. Those are some of the scales that are built in, but then obviously we can also create our own color scales, okay? So this interpolator, which is called, you can see this name, yellow, green, blue, it basically goes from yellow to a shade of blue. And in between we have some sort of shade of green, okay? So it says we can use this color scale that I just created in a variable called color as the function for our fill style in our circles. So the code along is apply the color scale to fill the style of a circle selection. So I'm going to give you 30 seconds for this. Let's see if you can do it. All right, so instead of basically just setting the color to be still blue, I'm going to use a scale depending on the data. So I'm just going to use my color that I just defined above. If I just rerun this, I'm going to get my numbers with a nice color and all of this. Okay. By the way, at this point, I'm going to make a parenthesis. I feel like I jumped right into the workshop without actually even presenting what is D3 or what you can do with it. Hopefully you know. But all right, this is the website. You have a lot of examples. Okay, I'm going to show you more examples later. But basically, it's this library that's used for basically drawing anything. Okay, things that you can animate, any sort of shapes, obviously, any sort of graphs or charts, like line charts, bar charts, area charts like this one. You can have scatter plots. You can have things like this, which I don't know what the name of this is, but you can create sort of tables with colors, all of this. You can create maps and projections, which is super interesting. Those are just shapes following data, which is like the borders of every country and every land, all of this. We can create obviously just normal bar charts and column charts, all of this. We can create more complex things like forces that attract each other, things like this. We can do these sort of DOM charts or graphs that display data in a sort of in a recursive way or in a hierarchical way. And obviously we can configure everything. The nice thing about D3 is that we're not limited by any library that gives us maybe just a line chart and a pie chart and something else. So we can create any chart that we want with any shape that we want, anything that we can imagine really. Okay? We can have things like this, super cool, in which we can calculate the position of the mouse, and depending on this, I can calculate the forces around each circle to make them not collide with each other, that sort of thing. Okay. Those examples, before the class, I just went into the website and I clicked a few of them. Okay. You have literally hundreds of them. And the nice thing is that all of those are open source, which means you can see how they were done. So you can maybe grab the code and use it for your own projects. And this is just in the D3 library, but then in the Observable, so Observable is this tool that was actually created by the same guy that created D3. And he has this guy called Mike Bostock, and he has a lot of examples, like hundreds of them, almost 1,000 examples, okay? For everything, like literally everything. You just Google it and it's gonna appear, okay? Maps, circles, projections, anything that you want, okay? Lots and lots of pages. I suggest you that you take a look at this later and you play around, okay? So that was the parenthesis, back to the workshop. So next thing, depending on the nature of your data, consider using a single hue, multi-hue, or divergent color scales. This is more like a data visualization thing. I'm just showing you like the technicals day-to-day, but obviously when you try to communicate data, you need to understand your data and you need to understand what you want to communicate. Okay, not every color scale is great for everything. Okay, this is important. All right, we can create our own custom scales with this little helper called interpolate RGB, in which you can give it an initial value and an ending value. And then it's going to create for you anything in between, okay? So the same, actually I'm going to use this one, I called it custom color. If I do use this in this, let's say custom color, and I just rerun, I'm going to have the circles with the color that I chose right here, okay? All right, so any questions so far? No, good. All right, so yeah.
Jeremy, just to let you know, there's a question in the chat. I don't know if you want to address it afterwards, but just in case you haven't seen it.
It says, hi everyone, my connection isn't great, so I haven't been able to follow everything. I want to ask if we have discussed browser responsiveness, or will it be discussed? I can discuss it later, yeah. It will be discussed. So, all right, where was I? Access. So with everything we've learned, we have the tools that we need to create access for our charts. Like we know how to, an access is just like a few lines and then a few numbers that gives us some context on the data. But this is a lot of work if we need to do this ourselves, okay? We need to create a lot of elements, text elements, and text based on the scale, then the lines and the colors of the lines. All of this is a lot of work. You can do it, but it's too much work. Since this is so common to use access for your graphics, D3 provides a library to do exactly this, okay? That is the access library that you can access right here. It's built into D3. And it provides very handy functions like this one. If you call D3.access bottom, it's going to create all the elements to create, well, an access to the bottom of your drawing. All that it needs is what scale are you using for this? Because it needs to know how to distribute the ticks and which numbers to put. And that's the nice thing. We can use the same scale that you were using for setting the position of the circles to draw the ticks of the axis. So if we create an axis like this, x-axis, to be D3.access bottom, and we pass in the scale, we can actually add this to our drawing with a special method called the call method, okay? And this is the next code along. It just tells you to add this right here when it says your code, and let's see what happens. I'm going to give you 30 seconds for this. All right, so I'm going to paste it right here and just wait. I'm just going to copy this first, paste it in here, and hit enter, okay? And this is what we get right away for free, which is, again, something we could have drawn. It's just a line and then a few lines vertical and then a few numbers, all of this, but it's sort of automatic, okay? I know that it gets cropped out. This is because I didn't add any margins, but I could do this eventually, okay? So this is super handy. All that I did is to append the little group element, and then I transformed this so it was in a specific position. If I were to change this and put just a 50, well, this would appear in the wrong position. I just want to put it at the end. So that's why the transform element is right there, okay? And then I just call the axis that I just created. That's it. So is this easy to create accesses in, I don't know what the word is. Is it axis? Axis with an A? Or is it accesses? Is it not a plural? I don't know. All right. So next thing, if this is clear, this is actually quite easy, just copy paste. Obviously, they have tons of examples for different accesses. Let's talk a bit about transitions, okay? So we've seen that we can change the data about selections anytime that we want. I have created a little function called update in the next cell, okay? When we can trigger that function by clicking on the button that I just added right here, okay? The way that I just, okay, plural is access, thank you. So the way that I created this, it's a bit, this is actually observable code, which is it's a weird thing, okay? That's how I created the button. Obviously, in plain JavaScript, we can create a normal button in the HTML and have an on-click listener, and when you click on this, we're going to trigger an update function that's going to look something like this. That's how it would look in plain JavaScript. In this case, it's actually quite similar, but I wrote it in a way that I could access this from the whole observable notebook. So the update function, I actually had to write it like this, okay? To this SVG node that I'm returning from this block of code, I just attached a new property, which is a function that's going to perform all the updating. So other than the actual syntax of observable, let's see what this is doing. What this function is going to do when I call it, it's going to select all the circles from my SVG. It's going to bind a new set of data. In this case, I have the same number of elements, okay? But the data is different than the one that I had. And then I'm just going to reset the fill, the center, and the radius to be my custom color, my linear scale, and my square root scale. So if I call this update, well, every element is repainted, it's repositioned, depending on the new data that I just bound to it. The key thing is always the data, okay? Data. Yeah? So I have new data, I bind the new data, and then I just perform all the styling and all the attributes that I need to do. And D3 is going to change everything. Every circle is going to recompute its position, its radius, and the color. That's it. That's what's happening when you click on this button. By the way, when you click on this button, you click once and then you cannot click again, because clicking again is just binding the same data, so nothing changes. Okay, a bit boring. This is why I created the second one, which says instead of hard coding the new data set, let's add a little helper function to create random data sets when we need them. Okay, that's just a function that I created. I actually made use of another little function of D3, which is the range function. And I did D3.range8, which means I want 8 datums. And then I want to map this to the random function. So for each one of them, just give me a random number. And then that random number, which is going to be between 0 and 1, hey, look at what I'm doing. I'm mapping this using my linear scale, another linear scale that goes from 0 to 1 to my desired domain, which is 1 to 300. So I know there's a lot of things happening in here, but it's everything that I just showed you before. Plus a couple of map functions that you know what they are for, hopefully. And I'm just using them. So I just did this so I can generate random numbers. Notice that when I call this, you can call this independent one, random data set. If you just execute this, it's going to give you a random array with numbers. If I rerun that cell, it gives me every time a different array of numbers. That's what I'm doing all the time, right? That's it. You see how cool observable is? You can just write things and just things happen. Nice. So that's what I did. The randomized data is going to do the same thing, but now it's going to make use, if you open the code, you're going to see that the data, I'm binding this to a random data set every time. That's all. Okay, so one more time, randomized data, and every circle is repositioned. All right, does that make sense? So that's sort of updating selections, binding new data and updating the visual attributes of this. So, all right, there's this. In D3, we can add transitions between one data set and the next, actually. So it will happen in a more understandable way for the human eye. Things don't change like this in life. There's always a transition. So to make things more human, we need to add transitions. So I basically, it says in the previous cell, add the transition method after you've bound the new data set and before you modify the style attribute. So if you just go at this, the cell right here at the top, you should see something nice happen. Okay, I'm going to give you 30 seconds, and then I'll do it. All right, so basically it's all that you have to do is this. After this point, this is in the update method, by the way, I'm going to add a dot transition. When we do this, anything that comes after the transition, it's not going to make a change immediately. It's going to make this over a specific period of time. There is a default period of time, and obviously we can modify this later on. So if I just rerun that cell that I just did, and then randomize the data, now I see at least some movement. So things don't change just like that. They move into their new positions, and also their color blends into the new color. It's quite fast, so it might be a bit hard to see, but that's exactly what's happening. Okay, I'm going to prove it to you. It says we can also define the duration of a transition, the easing of a transition, and the delay of a transition to fine-tune any animation that you want. So it says add a duration to our transition. After having the transition, you can add a dot at a duration 750. This is milliseconds, by the way. So 1000 would be 1 second. So let's do this real quick and let's see what happens. I'm just going to do it right away, okay? Oh, this is so cool. Thank you, Sophie. I was hoping for something like this. This is like the O moment. This is when it gets to get cool, right? All right, so I'm going to do this transition, add a little duration, 750. I'm going to rerun this. And hopefully when I run this, it takes a bit longer, okay, almost a second to make the transition. If you want to make it very obvious, I'm going to add one more zero, so it's going to be super slow, 7.5 seconds. And that's what's going to happen. Notice that every circle blends into its new position and color. All right? So that's pretty much what it is. There you go. All right. So I'm going to go back to the previous one. Or we're going to stay here forever. All right. It says still one more thing. What happens? We can modify the ease method that allows us to distort time control upon motion in an animation. By easing the time, animated transitions are smoother and exhibit more plausible motion. What that means is that I'm just going to open this curves, which is this. How do we move from one position to another position? Well, the easier way to move is the linear way to move, from A to B in a straight line. So that circle is here, it starts to move, and it ends here. The problem is nothing moves like this in real life. There's no such thing. There's always acceleration. Okay, a car starts accelerating and then it decelerates, etc. So it's better to use some sort of curve that's gonna feel more natural to the eye. Okay, it could be something like this that starts faster and then it slows down, or the opposite. You could do things that start fast and slow down, then they go fast again. That sort of thing. So D3 has a lot, and really a lot, of easing curves built in that you can actually even customize with the exponent that you're using, etc. This is all mathematical functions, and we're just fine-tuning every argument to it, okay? So we can have this sort of thing, that sort of thing, etc. We can even have a bit of, crazy things like this. Something could animate like this, okay? Or like this. You can try this on your own, okay? What I suggest you right here is, what happens if you add a little ease back out in curve? And then it says, hit your button for a bit of fun. So let's try this. Let's add this easing into our cell right here at the top, okay? That's what I'm going to do after the duration, add the easing, and then randomize the data. And I don't know if you can see this, but it basically goes back a bit and then it moves into the new position. Okay, what's happening is basically, let me just copy this, and I'm going to just put this. There you go. That's the one that I'm using. It's doing this. It goes back a bit, then it accelerates very fast, and then it slows down again. Okay, if you want to go real crazy, you could use something like this, but this is too much. Eh? I wouldn't use it in a real animation, by the way. But just for fun, let's do it. Okay, I'm going to run that cell. I'm going to randomize the data, and that's what happens, okay? Or maybe that other one that we saw. Yeah, this one is sort of a bit crazy, but I'm going to try it anyway. All right, let's try this. Let's rerun. All right, no good. Okay, you shouldn't do this, but just for fun, you can play around. All right, I'm gonna go back to the first one, which was this one, back in out. It's called. By the way, if you needed to, you could create your own easing transitions. This is just a function, so you can create any sort of shape that you want, something that goes back and goes up again, etc. Okay. All right. So moving on. Is this sort of clear at this point? This is all the concept that I wanted to show you. Okay. We saw creating elements, then appending elements, data selection is very important, then the enter pattern, and then the exit pattern. Sorry. And then I show you scales, color scales, axes, and transitions. There's a few more things in D3. I don't have time to cover. This is just the basics. So let's wrap all of those things to build a little scatter plot. Okay, with real data. Let's see what happens. Okay, in this case, we're gonna have just one cell to draw the whole thing. And if you scroll down, all the instructions are in here. Okay, step 1, step 2, step 3, but everything is going to be in the first one. So if you want to join me, let's do this one all together. Okay. So a bit of context. It says the data.json file. This is something that I loaded for you in this notebook. It's already loaded for you. If you want to know, by the way, they didn't show you this. If you scroll all the way down, there is an import section in which I'm importing D3, which is the library that I'm going to use. Okay, if you know JavaScript, this is like the import D3 from D3. This is the equivalent on Observable. Okay, and then I'm also importing other stuff. But then I actually imported the file, and then I'm using the file like this. Let me just show you. Go up, and my mouse is acting strange, by the way. So wait, I'm going to show you in a second. Sorry. So this file in this repository contains information on several countries in the world from the year 1900 to 2014. All right. So for every country and year, we have data about the income, the life expectancy, the population, and the continent that they belong to. Okay. The source of data is this, by the way. And then it says the x-axis in the plot will represent the income. The y-axis will represent life expectancy. The radius of each point is going to represent the population of the country. And this data comes to you in that format, okay? We have a very big JSON file with lots of arrays, and every datum is an object like this. We have those 5 properties, okay? Continent, country, income, life expectation, and population. All right, so that's it. And that comes for every year, okay? For every year, we have the array of all countries. So if you actually want to explore the data, this is the line in which I load the data, okay? I use this little helper called file attachment. If you were using plain JavaScript, you would just do like a fetch to get the data JSON, or you would just do an import to get the whole array in your file, okay? So if you want to open this, it's just a very long array, and every index is a year, okay? From the first one to the last one. If you open this, it tells you the year, and then countries is another array with all the countries in it. And then when you open this, look, Yugoslavia doesn't even exist anymore. It tells you all the data that's available. Notice that in some data, we don't even have the income or the life expectancy. I'm going to treat this so I can filter it out later on, so it doesn't give me any errors, okay? So this is just the structure of data, so you can understand this. It says, okay, we have the data available in this data object or this data variable. Then I'm going to define something for you, which is the margins of the chart. Since when we create a chart, we always have some margins for the axes to the left and some text to the right, etc. And that's sort of a standard thing in D3. So I just created a little object called margin, and I'm defining the margins to the left, right, top, and bottom. Okay. So I set the height to be 500 pixels. For now, it's going to be a set height. So I set it in the variable, and then our code starts here. I have a little play button. It's going to be very fun at the end. It doesn't do anything at the moment, okay? So our code belongs here. I started something for you. This is called the scan plot. And basically, I just create the SVG canvas for you. And your code belongs in here. And basically, we're going to draw the circles. We're going to add some axes. We're going to add some logic for updating the data sets. And that's pretty much it, okay? So the first part is to draw the circles. It says using the classic select all plus data plus enter plus append. I think I didn't say this. This is like a very classic pattern in D3. I think I wrote it, but I didn't read it. That's how we always create data. We have nothing. We make a selection of circles maybe, and we have no circles yet. So we bind some data, and then to the entering selection, we're going to actually append the circles, the real circles. Okay. So it says, let's draw one circle per country. All that you need to do is to copy this code into your chart. Okay. So let's just do this. I'm actually going to copy this, the whole thing, and I'm going to put it right here where it says draw the circles. Okay, hopefully this works. And I'm going to hit Command Shift. And if I scroll up a bit, I actually see a few circles right here. Okay, I'm going to give you 30 seconds, 1 minute. Let's make sure that everybody's in that page. Okay. Let me just read the code so it makes sense to us, okay? Because there was something weird in here that I didn't comment yet. So we're selecting every circle. We have no circles yet. Then I'm binding some data, okay? The data that I'm binding, this looks complicated, but it's not, okay? I'm binding data at 0. Wait a second, I need to, my mouse is not working properly. I need to reset it. All right, okay, back to normal. So data at 0, if I go up to the data, remember the data is this guy, okay? So data at 0 is the first object, which is the year 1900. And remember this has an array of countries right here. And every country has a few properties. That was the idea, no? So if I scroll down, what is this line of code doing? So for the first year, that's the data at 0, access the country's property. And first I'm going to filter it because I don't want those that have no income or life expectancy. Because I have some nulls that I just showed you. I want to prevent some weird errors because I cannot paint nulls. So I'm just filtering the array, okay? Everybody that knows JavaScript should know this function. If you don't know JavaScript, that's a normal function in data science. I guess you know what this is, okay? And then there's a little other code that I didn't comment on. I'm identifying every country uniquely by the country name. And then basically, that's just the data binding section. I'm entering, and then I'm appending circles, one for every country. I'm setting the radius to be 5. And then the center of the circle, hey, for every data that I have, for every datum, which is the whole object for every country, I have access to its income. So I'm going to use the income for the X position of the center. And the life expectancy for the Y position. We said that the X-axis would be income, the Y-axis would be life expectancy. So that's what I just did, but the drawing is actually quite ugly, okay? So that's the first part. So it says, it doesn't look too good, does it? That's because we're using the raw value from the income and the life expectancy. What if the income is, whatever, 1 million euros? Then it's drawing this in 1 million pixels. We don't even see this. Actually, this is drawing everything, but you cannot see it. It's far beyond the borders of the screen. So how do we solve this? By adding scales. It says, let's add some scales to fit all our circles within the bounds of the canvas. We will use a linear scale for the y-axis and a logarithmic scale for the x-axis. Okay, so what I did for you is to create the axis for you, or the scales. The x-axis is going to have a logarithmic scale in which the range is something from the left margin and then the width minus the right margin of the canvas. This looks a bit weird, I know, but this, I defined the margin before. And then I know what's the width of this width that you can see right here. It's created by observable, okay? If you want to set this to 720, you can just hard code this to 720, okay? For now, please just leave this to be the width. And then the domain is the domain that I know the income goes from. Okay, it goes from 200 till something like 150,000. Okay. Then the y-axis is life expectancy. It's going to be linear scale, and it's going to go from the top to the bottom. That's the range, and then the domain is going to go from 0 to 90. Okay, I know that the minimum life expectancy is 0. The maximum I want it to be 90 years old. Okay. By the way, I know that I'm putting the domain after the range. It doesn't matter. I did it the other way before. Might be confusing. The order doesn't matter. Okay, I'm just creating the scale. So now that I created the two scales, which are called x and y, and they are functions, we can copy these into the code. Basically, this is what I'm doing. Okay, notice if you can see the difference. I'm not using the income directly. I'm passing the income, I'm processing the income through the scale that I want to represent. So you can actually copy this. I'm just going to copy the last two lines of code, and I'm going to go up, 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 and I'm going to replace those two lines. So it's not going to be d.income anymore. It's going to be d.income processed by the x scale. And then same thing for the y scale. If I just rerun that cell right now, well, I get something visible at least. Everything is within the bounds, okay? In which the lower end vertically is 0, the upper end is 90, and then to the left and to the right is the minimum and the maximum of the income of the country. Does that make sense? All right, so we could draw some circles, then we could fit the circles into the scale, which is into the canvas, which is using scales. Very good, let's move to the next thing. It says, copy this code into your, sorry, not this. Add some axes. Without axes, data is very hard to read. Now that we have the scales, we can use them to draw the x and the y axis to the plot. So it basically tells you to copy this code and add it to your graph. Okay. Quick note: I'm going to read this. That's how we created the axes. I'm going to append a group, and then I'm going to transform this to position the axis, and it's going to call an axis at the bottom in which I need to pass in the scale that I'm going to use. Okay, that's the scale, the x, the scale that I just created. And then in this case, I'm using another modifier, which is the ticks. I can define what's the width of the ticks or what's the text and all of this. Everything you can customize it, okay? And then same thing for the y-axis. I'm creating an axis to the left using the y scale. If you just copy this, it says add some axis. And you put this into this add some axis region, add some indentation, and you rerun that cell. Now you have some context, okay? You can visually see the scales, life expectancy to the left and income to the right. And look at this, how cool this is. This was a logarithmic scale on the x-axis. So it knows this, so it automatically draws, you know, logarithmic ticks in the right position. Okay, because this is going to grow, since this goes from like 2 centuries ago or whatever, the income changes so much because it's the absolute value that we would have an axis that would be too wide, okay, if we want to represent all the transition between every year. Instead of doing this, that's why we use a logarithmic scale, okay? Hopefully you know how it works. It's going to compress basically the bigger values, okay? All right, so hopefully this makes sense. I'm going to jump to the next one. This was adding some axes. Then let's do this one. Radius represents population. Let's create yet another scale for population and use it to calculate the radius of each circle. So first, I'm going to create a scale. I'm going to call it R. That's it, just R. And it's a square root scale. And the domain goes from this. Okay, this number is it's 5 times 10 at the 8th. I don't know how to say those numbers in English. Hopefully you know what this is. And the second thing is the range for the population. Sorry, for the radius that I want. This means that the minimum population is 0 people. The maximum population is like 50 million people. Is this 50? Or is this, no, that's not 50, that's 500? 500 million, yeah. Because we have China and India in the latest years, they arrive at that population, okay? And then the range is, okay, the minimum radius that I want is 1 pixel. The maximum radius that I want is 35 pixels. So now that we have the R scale, let's use this to set the radius. So you can just copy this and replace the radius, okay? Notice that what we're doing right here is, what is it? Instead of saying a radius of 5, I'm going to set a radius based again on data. For every datum that I have, I'm going to grab the population, I'm going to run it through the radius function, and 1, 2, 3, there you go. Now I can start to see something. Can you see those big things right here? I bet you this is somehow China and India. Okay, the biggest population in the world, even in the year 1900. Okay, the other ones I don't know. Well, I just made that up. Maybe it's not the case, so just scratch that. All right. So now actually this actually starts to make sense. Okay, you can see sort of the trend, how things work. Okay, and how you can actually start to see some information. Right. That's what data visualization is good for. If you read this graph, you can see that the bigger the income, well, the higher the life expectancy. Who would have said, right? The more you go to the right, the circles go more to the upper part. It goes like this, obviously. It also tells you that the bigger countries, maybe those that are too big, they're actually in the lower part of the graph. I don't know, maybe there's a correlation, maybe not. That's why we export the data. So I'm going to go down again. That was the radius. Any questions so far? Are you following along? I'm curious, how many of you are actually following along during the code? Okay, a few of you. Nice, good, good. So let's style the circles a bit. It says we can't see much with all the circles overlapping, that's true. Let's add some styling. The color of each circle will represent the continent they belong to. Okay, so let's have another visual clue of the data that we see. It says we will create an ordinal scale for this. It's those scales that they only have, discrete values. Okay, one per, in this case, continent. So I create this new scale called scattered color, and it's an ordinal scale, and the range of that scale is defined by this color scheme. Okay, this color scheme, it's the one from Tableau. Maybe you've heard of Tableau. It's this guy right here at the bottom. You can use any of those that you want. Okay, I'm using the last one. It's not the previous, but it's the one. So if we do this, it says now you can use this for the fill and the stroke attributes of the circles. So basically, I'm adding this. Okay, those 3 lines basically I'm adding. I'm setting some opacity for the fill. I want everything to be a bit transparent, 0.4. And then the fill attribute, it's going to be obviously a function of data in which I grab the continent and I pass it through the scatter plot color, the scale that I just created, which is discrete, okay? And same thing for the stroke. So if you just copy those 3 lines of code, actually, that's enough. You just copy it, go back up, and I'm going to paste this right here. And hopefully 1, 2, 3, run the cell. Doesn't work because I added. Careful with the semicolons, okay? So if you have a semicolon, you can have a dot. Samantha, were you having the same issue? Because you did like this. All right. So I'm going to run this again, rerun, and there you go. A bit of color, okay? So at this point, we don't know which color was assigned to which continent. Obviously, we can set this. I didn't do it in this case, but I can guess that the blue is Asia. Again, for China and India. The other ones, I'm not so sure. Maybe the red is Europe. I don't know. But again, we have more context. I added some opacity so we can see everything that's actually hidden behind all the circles, etc. All right, so scrolling down a bit more. We style the circles. So let's update the data. Okay, we're seeing the data for the first year. We have like 100 and something years more to go. So let's add something to the update function. For this exercise, you can just copy paste, obviously. I'm going to explain what I'm doing. The update function is going to accept an index. Okay, the index is the index of the array that I want to plot. So if the index is 0, I'm going to be plotting the first year, which is 1900. If the index is 1, I'm going to be plotting 1901. Okay, that's all. So when I pass in the index, what it's going to do is, again, select all the circles, bind the data again. In this case, it's data at index. Okay, it's not data at 0. That's the difference. data at whatever index I chose, the 10th, the 20th, etc. And then it's going to set the rest of the things exactly the same way. Okay. Notice that I don't have to reset the colors because the population of a country might change, but the continent is not going to change. Okay. If something is in Asia, it's going to be Asia forever. No. So that's why I don't change those properties. I'm just going to copy this and I'm going to go up in here, and I'm just going to replace, okay? And I'm going to rerun this. Nothing changes, but now there is a difference, which is something that you can read in here. It says, play around with the range selector to see what happens, okay? That part, I did it for you. But again, if this was plain JavaScript, you would just have a function called update, and you can have a range selector bound to that function. If you know React, this is easy to do. If you know Vue, this is even easier to do. And then you can just bind the value of that input and pass it to the update function. Every time that you move something, you're going to update something, okay? This is a use effect or whatever in React, okay? So that's what's happening right here at the top. If you just if we just click in another year, we're going to see the data for that year. You can actually drag the selector and see how data changes, all right? And all that we're doing is this. Remember, the data is this. So I'm either binding the data at position 0 or data at position 7 or data at position 18. Doesn't matter, okay? I did the code for you. If you're interested, you can open this. Sorry, the data is actually below in the code. I'm going to show you later, okay? But that's all it's doing. It's taking the index of the array, it's passing it through the update function, and then it's re-rendering those elements. That's it. So just one more thing to do, and I'm quite happy with the time. It's 8 o'clock. We were supposed to finish at sort of 8:10. So that was updating data, and then it says animation. It says let's add some transitions to the data updates to please the eye of our viewers. Your update method should look now like this. All that I do is to add some transition and some duration. Okay, so I'm just going to copy those 2 lines of code, and going to go up again. And I'm going to add this after the data selection. So in the update method, right here, I'm going to add the transition and the duration, which means I'm going to run the cell. If you click on any year, it's actually going to animate to that year. Okay, bit of animation. I'm going to scroll down just a bit more. Okay, we're in the animation section. It says, are you feeling painful? Try to change the easing of the transition. Okay, the same thing that we did before. We can do it in here. I'm going to copy this. I'm going to go back up to the code. And in the transition, we have a duration and we have an is. I'm going to run the cell and let's see if it works. I don't know if you can see it with my internet connection, but when I click on a button, it takes a while to actually do it, and then it goes super fast. Okay? If you want to try any other easing curve, like one of the crazy ones, not recommended, but just for fun, we can do this, okay? I'm going to change this. I'm going to say this is that function. I'm going to rerun the cell. And then when I change this, well, that's what happened, okay? It's a bit, it's like trembling a bit, okay? So I'm going to go back to the previous one. It was called isIn. I don't remember. isIn. What did I call this? isExp_in. Sorry, my bad. Let me just replace this. We run. Okay, so that's pretty much it. The last part, it says autoplay. The autoplay is already done for you. Okay, that's what I mentioned before. I just created an array of years. If you were interested, this, guess what? It's just a map. Okay, for every data that you have, just grab the year, and I have an array with all the years. And then what I'm doing is, when I click on the button at the top, I'm going to run the play button. I'm going to run the update one after the other. Okay, and every time look at this, I'm passing in the index minus 1900, not the index, sorry, but the year. So if it's the year 1900, if I subtract 1900, I'm going to get the index 0, which is the index of the array that I want to use. So don't pay too much attention to this. This is already done. If you just scroll up, all that I'm doing is animating automatically. So you can see how these evolve through the years, okay? And it's actually quite interesting because at some point you can see like something happens super weird, which is World War II or World War I, in which the life expectancy just drops dramatically, okay? So that's what's happening in those things. So let's just advance with the 70s. Everything is moving to the right, so countries have more income, etc. But the linear tendency is still quite clear, okay? So can you see the green? I would bet that the green is, wait, I'm gonna stop. I would bet that the green color is Africa probably, because it has the lowest life expectancy in terms of the income of the countries, I think. And probably those two things, those two big things, obviously they were India and China, the blue circles. And then whatever is to the right, I don't know what it is. I guess that we can actually check this. I could actually put the names of every country over every circle, all of this. I just didn't have time. But probably I would say that either orange is Europe or maybe red is Europe and the other one is America. I don't know, okay? I don't know. We can investigate this later, okay? All right, this is it, okay? That's what I prepared for the workshop. And did you like it? Did you enjoy it? Did you follow along? So this is, honestly, this is just like the surface of D3. You just saw the basics and then the basics applied to actually do something. But there's so much more that you can do. You can draw any shape, any transitions, change your data, any animations, anything that you want, okay? I do recommend that you go see the library and browse a bit. I added a few links in here for you, a few references, which is obviously the D3 website. A lot of notepads. Okay, my mouse is gone again. Just give me a second. All right. This guy is a genius, okay? He has a lot of things for everything. And he has tutorials to learn stuff, all of this, okay? So very, very recommended, both for just learning data visualization, like concepts about when to use a color or not, and then for actually using and learning D3. Lots of resources. I added some links to the official packages, for instance, for making accesses or scales. So you can open this in GitHub, and you can see that package D3 scale, which is built into D3, and how it works, okay? All the continuous scales, all the ranges, all the range rounds. There's a lot of functions that we can use. We can invert the scale, we can clamp a scale, things like this. All of this is built in. All of utilities that you will need if you use data visualization tools, okay? So I added those links right here at the bottom. There is a very cool one. It's called Learn D3 from the creator of D3. It's like, it's 7 or 8 episodes, okay, those things right here. And it gives you a few examples. It talks about binding data, scales, shapes, animation, a bit what I did, but much more extended, like 1 episode for each one of the plots, okay? I wanted you to see a bit of everything so we could construct the scatter plot, but you have way more to go in here. I like this one because it's from the creator of D3, so no one knows better the library than himself, but there's a lot of contributions from other people that's super interesting, okay? And then I also added these observable tutorials. If you're interested in using observable, they have a few tutorials. For instance, those, it's like 5 minutes each. There are videos. They tell you how this works. So you can actually start using it if you want. Usually, in my case, I use observable to just quickly, prototype or wireframe some idea that I have on a graphic. But then eventually, I actually build these in just plain JavaScript, or JavaScript within React or Vue or whatever in my applications, okay? But just for exploring the data and trying some things real quick with no installations, no nothing, observable is pretty cool, okay? So at this point, I guess we can take some questions. The first question is actually something that someone wrote. Thanks, Luciana, kind as always. So Catherine wrote, my connection is not great, blah, blah, blah. I wanted to ask if we had discussed browser responsiveness or this will be discussed. I'm guessing that by responsiveness, you mean sort of if we can adapt the graphics to the width of the screen. Is that the responsiveness you mean, like the CSS responsiveness? I don't know if she is still in the session.
I have a feeling she's left the session.
Okay, she's left. So, okay, I'm going to answer him. So, yes, we can make this responsive because since we can know the width of the page, and we can know this with JavaScript, by the way, there's a little command which is window dot, I don't know, get inner width or something, or you can even get the width of every element in the page. Hey, remember this is just DOM manipulation behind the scenes, so you can target any element, get the width, and use that width to calculate all your scales and all your data. This is actually something that I did, even though you didn't see it, which was this. I told you to sort of ignore this, but in the code that I created, sorry, not this one, but another one, I don't know what it is. Well, at some point I used width variable. I don't know if you remember. That width variable, I didn't create it, it's already unobservable, and it's a variable that's going to change when the width of the page changes. So that the same logic you can do it yourself, okay? In plain JavaScript or in Vue or in React or on anything like this, you can just listen for changes on the browser, and then when that happens, you can trigger an event and maybe change the variable that holds the width for your canvas, for instance, and then just redraw the elements using that width. So short answer, yes, it can be responsive. Okay. Any more questions? Anybody? You can unmute yourselves and ask the question, and you can ask them in the channel. Okay, so Sophie said, can we bind data to images instead of SVGs? I'm not sure what you mean with this. What do you mean to bind data to images? Can you clarify that, Sophie?
I'm going to unmute so it's easier to explain. I'm speaking about my own experience because I'm trying to basically create a map out of tiny little PNG like things, but I don't know whether it's if that's even good practice. Would it be better to just use SVGs when?
I mean, what are the images? The little images, what are they?
They're like tiny little eyes.
There is always, I remember you mentioned this last time. Oh yes, I remember. So the eyes, are they always the same eye? They are different, something like this?
There's two types. There's a brown eye and a blue eye. So there's only two PNGs or JPEGs.
All right. I wouldn't use images for this. I'm not saying that it's not technically possible, but it's too much for what you want to do. What I would do is have the little shape of the eye in SVG format. Like even the code, like which is like a circle or something like this, we can even put this in a function called draw eye. And then for every piece of data that you may have in that map, which has a specific position, using something like D3, you could draw that eye, which is just a circle plus another circle plus maybe a surrounding circle, I don't know. You can draw that eye in that position of the page. Obviously, I would have to see the exact code that you're working with.
But it's always like to do this with PNGs is never a good idea, basically. It's not.
I mean, it's the same. I wouldn't do it with PNGs. No, I wouldn't. It's not that it cannot be done, but it's not the best practice, I would say.
Okay.
Unless, I mean, obviously, if the drawing that you have is actually an image, not just something you can draw with a PNG with an SVG, but like a real picture of something, then well, you will have to use PNGs. There's no other way, I guess. I'm not saying that you even need D3 for this, by the way. D3 is just good for positioning things and stuff. But in that case that you're mentioning, if you want to use PNGs, I would use PNGs inside of a canvas, which means a canvas element, not an SVG element. I didn't talk about the canvas element. It's another element in HTML to draw things, for instance, to put pictures in it. Okay, so it can be done. There is maybe another library that would help you for this, which is the P5 library. If you've heard of processing, P5 is the same thing for the web, and it's different than D3. It's completely different, but it's easier to draw things on a canvas based on position. It's very easy to load an image, for instance, your little PNG for the eye, and display it on a specific position on the page.
Okay, good to know.
All right.
Thank you.
All right. More questions?
Yeah, I have a question.
So in the example of the scatter plot, before you updated the data that we've seen, what was it? Just 1 year or?
The first year. So the data that I draw in the first place, which is this one, it was the data that I was binding in that line of code. And that line of code is taking data at 0. This data right here is is this data right here. And data at 0 is the first one, which is the year 1900. So yes, I started it with the first year of them all. And then when I click on the update button, I go 1 year at a time. And then I just, on my update method, which is right here at the bottom, instead of doing data at 0, I do data at any index that you want.
Mm-hmm.
All right?
And you always start at index 0. So you
No,
have
in this case, yes, I think it makes sense to start with the first year. Maybe you want to start with the last year. It could also make sense. Let's see the last year from scratch. Where I will do data at data.length -1. You all know what this is. It's not working. Why not? Data.length -1. It's not working probably because I hit the play button before, so it's still set to the first year. Okay? If I set to the last year, that's what you will see if you refresh the page.
Mm-hmm. Okay, thank you.
Okay, more questions? No? Everybody's good?
Just a quick one. What would be the best practice to get an icon image or whatever into an SVG? Would it be Illustrator or the other options?
So, all right, icons, images, etc. I mean, I guess it depends. Like if you want to use just emoticons, like the ones from WhatsApp or whatever, those are actually now valid as text, which means you don't need anything. You can actually copy it and just paste it somewhere, okay? Let me just grab an emoticon somewhere. Just give me a second. Very, very quickly. So let's add a little face. I'm just going to copy it. And if I use this anywhere, I'm just going to add something in here. I'm going to say, face equals this. Oh, wait, it doesn't work. Just a second. Huh? Copy this. Does it work? Yeah. Can you see that I just added a little? Okay. Since this is a string, it doesn't let me add it like this. I need to add it like this. Okay. But an emoticon is actually a valid character of the alphabet. Okay. Which means you can use it directly inside of SVG, because in SVG you can actually draw code. Sorry, text. There is a text element, and you can just put text in it. So that would be a way of drawing an emoticon. To draw images or icons or any of this, well, for icons, if you have a vectorial icon and you have it in Illustrator and you can export it as an SVG, that's what I would use. That's what's usually done. Okay, if you have the vectorial version, which is the SVG, use that. For normal image, like just what Sophie asked before, I'm not sure we can insert a normal image into an SVG. To be honest, I've never done this. Image into SVG. Let's just Google this. Online SVG, blah, blah, blah. No, I'm going to put image inside SVG. Well, it looks like you can. Oh, yes, you can. There you go. There's an image element that you can point to an image. So yes, you can do it. Which basically is also the answer to Sophie, your question. Yes, you can use an image directly into SVG, so you could also use D3 for this. You have like the two alternatives, okay? Either using P5 in a canvas or using an image element in an SVG that you can manage with D3 or something like this. All right, any more questions?
Just a quick one. I've also, I think in the last month or so, you get SVG fonts as well.
I don't know. To be honest, I don't know.
Yeah.
Okay.
Yeah. But that, yeah, I suppose like, yeah, anyway, I'll figure that out.
If it's an SVG font, I don't know. I'm going to Google it and I can contact you later and can tell you, okay?
Okay,
Yeah.
cool.
I would need to see how this fits into the normal or the classic SVG paradigm.
Yeah.
But it might work. I mean, if it doesn't work, it's going to work in a bit of time. Okay?
All right. Thank you.
All right.
I have a question.
Hello, Frida. What's your question?
Hi. Yes, this is a silly thing, but you remember when I did the boot camp and we were looking at your portfolio, that you had these things moving with the mouse? Did you do that with the D3? You know what? Remember what I'm talking about?
My portfolio? What do you mean my portfolio? Like my website?
Yeah, the website you had, you know, there were like these things that were moving with the mouse. Do you remember this?
Ah, yes, I guess
This-
so. I think you mean this.
Yeah.
Wow, this is so old.
Yeah.
All right, sorry. This is weird. You mean this, no?
Yeah, this.
You
Yeah.
move the mouse. No, this is not done with D3. This is another library that you can just install. It does this for you. But now that you asked, you could totally do this with D3. Okay, there's a lot of examples of moving. I'm just going to close this. I don't want to look at myself. There's a lot of examples in D3 for particles that move and forces. Actually, one of those that I show you, it's a bit of this. Can you see that I can move my mouse and the circles
Yeah, exactly.
go
This
around?
is what made me think of that kind of.
Exactly. That one, no, that one is not done with D3, but it could be done with D3. Yeah.
Okay, thank you.
All right. Any more questions? No, you're good. All right. So that's it. Keep playing with it. Keep playing with Observable. Okay, it's quite fun. If you are a member of CodeOp or an alumni, you can reach me obviously in Slack as always. If you're not, and if you're just new into this Zoom call, welcome. Thanks for joining us. And we teach at this super cool coding school called CodeOp. We do some JavaScript bootcamps, and we're going to do a lot of cool things so you can sign in and learn stuff. All right. There you go. That's my advertising. All right. So if you have no more questions, I'm going to say goodbye. Pleasure seeing you all. All of you that I don't know and all of you that I know. Such a pleasure. I haven't seen you for a long time, some of you, so nice to have you back. All right. Yeah. Now I see all the faces. Yeah. All right. I'll be around. Take care. Have fun. I'll see you soon.
Thanks, Germinal.
Thank you.